Hi everybody, it's Jamie here, one of the product managers for Solid Solutions. Welcome to this webinar all about upgrades. So this is all about what's included if you have the professional, the mid-level package, or the top-level premium. So obviously SolidWorks has a huge portfolio of other products that sit either alongside it or in it. For example, looking at data management or looking at manufacturing. We've also got some great tools for electrical design, but actually what we're going to concentrate on today is the mechanical design. So the kind of core SolidWorks product that we all know and love. So here I've broken it into the different versions you can get. So you've got standard, which is our cheapest basic level package. Then we've got professional, which is in the middle. And then we've got premium. So you can see here what's included. And I just wanted to spend a bit of time really just going through each one of these to explain what you'd get if you were to upgrade from standard to any of the other packages, that being professional, premium. So let's start out. We may as well work left to right. Let's have a look at what's included in Visualize Standard. So this comes in the professional package. This is actually a standalone product as well, so you can actually have this on a separate machine if you want to. But it's basically a way of creating super high quality, really nice rendered photorealistic images. So you can see those examples on the bottom there. Stunning, I'm sure you'll agree, but it's really simple to use that. I'm actually going to have a look at this as well in a bit more detail in the software in a bit. But just to show you the kind of things that we can do, it's really nice because it's just simple drag and drop, and we can literally just tell SolidWorks where we want to render this, whether it's in a studio or an outside environment, but it does create some absolutely stunning images. So that's really one of the main reasons that people go for the mid-level package, because you get this included. So this is free of charge. And as I said, it's a standalone package as well. So if you wanted to have this on a separate machine, then you can do that too. So that's SolidWorks Visualize. So we get that. We also get PhotoView 360. Now you'll be familiar with this, I guess, if you're using professional already, but this has been superseded really by, or replaced by SolidWorks Visualize. So PhotoView 360, it's been around for a while now. Again, it's a render engine, but it's not quite as good. I'm sure you'll agree that the ones in the previous slide were a lot better, but we can still create some what I call quick and dirty renders, which will help you to realize your products in 3D, but obviously with some realistic textures and things like that. So that comes included as well. Obviously, if you're using professional, you may as well use the Visualize part of the software. But this is what I call for quick and dirty. So if you want something really quick, then this is often a way to go about it. We've also got PDM Standard. Now this is included in the mid-level package as well, and it's basically a way of looking after our data. So we use what we call a vault system that basically allows us to control our data, so things like revision control and things like that. It uses a user-defined workflow, so you basically decide how you want it to work, and then it's tailored to that. So for example, certain groups of people maybe can contribute, other people maybe can only see things that are in an approved state, for example. So it really does help the business to control your SolidWorks documentation. It increases search efficiency as well. So if you're looking for parts, there's some really nice tools in there that allow us to search through previous projects for certain parts. And as it says there, it kind of enables a workgroup environment. So if you've got 2 or more people working on a product at the same time, then this is a really good way of managing all of that kind of data. So that's included as well. We've also got the SolidWorks Toolbox. Again, we're going to have a look at this one in a bit more detail in a second. But this is a fully integrated library of parts. So we've got kind of all the nuts and bolts and widgets and washers that you might like. And as you can see by some of the graphics there, we've got the global toolbox. So no matter where the product that we are designing is going into market or maybe manufactured, then we've got all of the nuts and bolts specific to that type of standard. It's fully customizable, so we can add specifications to each of those or particular part names or numbers. And also, we've got the ability there to use a beam calculator as well. So we've got a beam calculator that allows us to calculate the stress and deflections of beams. We've got a bearing calculator that does the same thing. And we've also got a standard library of grooves and things like that that we can add to cylindrical parts as well. But I'm going to go into a bit more detail in that one as well, because again, this is one of the other main reasons that people would go for the mid-level package, because it's a fully automated way of bringing in those parts into our assembly without having to model them and also mate them up as well, because this actually brings in all the mates with it as well. So a really nice tool for that. We've then got the design checker. So the design checker basically checks documents to make sure that they are adhering to certain design criteria. So things like dimensioning standards, things like sketches, making sure they're all fully defined, making sure the correct materials are being used, fonts and things like that. So it's basically just checking over the document as a checker would do, just to make sure that everybody's using the right font, for example, or in the same size. And it's just a way that it can do it fully automated, and we can actually let this sit in the background and check our documents over and give it the kind of first eye over before it actually maybe goes to be checked by a human being. So it's a really nice automated tool for being able to do that kind of stuff. We've then got Task Scheduler. Now this is a really cool tool that basically allows us to do things like batch conversions. So if we wanted to, for example, take a technical drawing and we wanted to save them into both a DXF and a PDF format, instead of doing that manually for each drawing, we can create all of our technical drawings, and then maybe over lunchtime or overnight, we can say to SOLIDWORKS, look, take all those technical drawings and save them out into DXF and PDF files for me. We can also run simulation studies. So obviously they can take some time, so we can actually set it up, tee it up to solve overnight perhaps. We can also rebuild large assemblies. So if we've got huge assemblies that are taking some time to rebuild, we can actually say to SOLIDWORKS, look, do this just before I get in the morning, or maybe after work. What's nice is that it runs separately from SOLIDWORKS. So again, you can have this running on the side and still use SOLIDWORKS if you want to. But it's a really nice way of just saving yourself some time. And again, it's all about kind of stopping those repetitive tasks, if you like. And we can schedule tasks to be performed, as it says down there, just the once, so just a one-off, or we can do it on a daily, weekly or monthly basis as well. But it's just allowing us to set up tasks for a future time. So again, a really nice tool available in the Pro package. eDrawings Professional. Now some of the functionality from Professional 2018 has been just put into Standard 2019, but certainly in the Pro version of 19 we can stream augmented reality experiences through the Microsoft HoloLens, which is what you see on the left there. So we can use augmented reality within eDrawings. We've also got the ability to launch virtual reality experiences in VR headsets such as the HTC Vive, which you see on the right hand side there. And we're also able to save eDrawings using the Pro functionality into eDrawings Web HTML5 as well. So we don't actually need to necessarily have it as an eDrawing standalone. It can actually sit on the web using HTML5. So that's something to have a look at as well in a bit more detail. That is a really nice way of being able to host that kind of stuff online. So that's in the Pro package of eDrawings, which is in the Pro package of SOLIDWORKS. We've also got the ability to do some part costing. Again, we're going to have a look at this in a bit more detail, because this is another reason why people go for that mid-level package. It basically helps us to calculate the rough costs of components. So sheet metal parts, machined parts, welded parts, 3D printed parts, plastic molded parts, also cast parts as well. So any part that you might use a lot of, or you might be creating a lot of, then we can use this functionality to basically create us a rough cost. What's nice is that if you change the design as well, then that cost breakdown will automatically change real time to give you the new costs involved, or if you change materials or something like that. So it's a real kind of, it helps designers to make those decisions on what to manufacture it out of, but also if you're a manufacturer yourself, it's a very quick way of creating quotes instead of kind of finger in the air or going through some kind of manual process. But it's a very, very powerful tool at being able to judge what the rough costs of parts might be. So that's another great tool to be using in the Pro package. We've also got CircuitWorks as well. So that's allowing basically conversions or collaboration between ECAD, which is electronic CAD, and MCAD, so that's mechanical CAD as in SolidWorks. But it just allows the ECAD and MCAD guys to work in collaboration to do things like fit and function. Also being able to generate 3D geometries from your IDF files. So IDF is like a standard PCB format, but we can also support others such as PADS, ASCII, PowerPCB and ProStep EDMD as well. So those are all formats that are supported by CircuitWorks. So again, it's just a way of collaborating really between ECAD and MCAD designers. So that's included in Professional as well. We've got Tol Analyst. So this is basically a way of looking at your tolerances over models and working out what the minimum and maximum tolerance stack would be. So obviously this would be pretty difficult if you were to do this manually. So this is just an automated tool of being able to calculate things like the min and max root sum squared of tolerance stack. So all of these, fairly complex stuff, if you, as I said, to do it manually is very time consuming, but it also lists things like contributing features and tolerances as well. So any tolerances that are causing the issues, you can then go in, make some changes, and then run this again just to see kind of best and worst case scenarios, if you like. So it's all about tolerance stack up, and it's again a very useful tool sitting in our Pro package. We've also got the ability in the Pro package to look at Scan to 3D. So this is a utility in SolidWorks that basically opens scanner data. So usually a mesh or point cloud file. So things like XYZ or STL files as well we can bring in. But this is basically a way of turning it into a surface or as a solid model. So often if you're just given cloud points, it's actually pretty useless unless you're going to turn that into a surface. Now there are other packages that we also resell. One is Geomagics for SolidWorks, which is a great tool, slightly better I guess than this one. If you're going to do this all the time, you'd probably want to invest in something like that. But again, for little jobs where you've got some scan data that you want to include in a SolidWorks model, this is a perfect utility to be able to do that. So that's Scan to 3D, and that's also in the Pro package as well. So those are all included in Professional. As you'll agree, there's quite a lot there, lots of productivity gains, lots of big time savers. Then down in Premium, we've got the really good stuff. So we've got things like routing. So let's just have a look in there. So this is basically a way of automatically creating like special types of sub-assemblies for pipes, electrical cables, tubes, HVAC, stuff like that. So you can see by the images there that, to do this manually, you'd be using lots of 3D sketches, lots of kind of additional curves. So with this, we can literally say, look, I want to go from this piece of equipment over to that piece of equipment over there, and it will work out kind of automatic routes. And we can specify things like standard lengths of things. But it's just a way of automating that function, because obviously if you're doing this all the time, they can be very, very time consuming. So instead of doing it manually, we can actually just do it using this routing functionality. And as you can see there, we've got the ability to use piping, HVAC, so rectangular and circular ducting, flexible tubing, cable trays, ribbon cables, electrical conduit, flexible cables. So it's all there. Whatever you need to route, we can do that within SolidWorks Premium using the routing utility. There's some really nice videos online as well on our My Solid Solutions. There's some really great videos on how you can use this in your designs. So really big time saver. In the Premium package, we've also got simulation. Now you'll know already that in the standard package of SolidWorks, we've got the great tool that allows the designers the power to do the kind of, what if I change the material, what if I change some of the geometry, what does that do to my part? Because in standard SolidWorks, we can do a stress test on a single component, a single body. Whereas in SolidWorks Premium, we can actually do that on an entire assembly. So you can see here this graphic just showing you that we've got an entire assembly that's being evaluated there, not just a single component. Now that's really important if you're doing anything more than an individual component at the end of the day. It's obviously really sensible to include all of the parts that might be in play when you're doing a simulation study, instead of kind of ignoring certain things. It allows us to avoid failure. We're not suggesting that you're not going to do any testing anymore, but hopefully you'll be testing a product that would be better because you've tested it in SolidWorks first. And it can define things like factor of safety, so it can calculate that. It can also show us high and low areas of stress, and we can look at strain and displacement as well. So is this thing moving and how much by? So it's a really great way of kind of saying, what if I change the geometries, make it a bit stronger in these locations? What does that actually do to my factor of safety, for example? Or, could I take material out to make this thing lighter and cheaper, for example, but still allow it to function in the way that we anticipate? So again, that's the main kicker really for SolidWorks Premium, the fact that we're able to do simulation studies on entire assemblies. Then we've got motion. So motion is a great utility in SolidWorks that allows us to determine how our mechanism is going to work. So if we're designing things that have got some kind of mechanical system in it, then we can make sure and evaluate that's going to work. We can look at clearances and interferences throughout the entire range of the motion. So that means if we've got something that's dynamic, then, yes, okay, does it foul in this closed state or in its open state, but actually anywhere in between those states as well. We can have a look at how forces affect the mechanism. We can also look at reaction forces and torques and things like that as well, and accelerations, velocities. So we're able to evaluate that inside of motion instead of doing it the long-handed way. But that's a really great tool for being able to validate that kind of stuff instead of having to make it or work it out longhand. We've then got assembly costing. Now we've got costing obviously in professional, as I've already pointed out, but that's just for single components, that's for single parts. Down in premium, we can do that on the entire assembly. So that means that we're able to also include the parts of, or include the cost, sorry, of other parts in the assembly, but also things like the purchased components as well. So if we've got nuts and bolts and widgets and washers from our SOLIDWORKS toolbox perhaps, then we're able to include those costs in there as well. We're also able to add custom operations as well, so painting, anodizing, assembly, that kind of stuff as well. So it's a really great tool for being able to remove the kind of finger in the air quotation. We can get something that's actually based on hard and fast numbers. So again, a really great tool sitting down there in SOLIDWORKS Premium. We've also got sustainability. Again, this is possibly underused. I like to try and use it wherever possible, but it looks at the environmental impact of our designs throughout the life cycle as well of the product. So not only just from manufacture, but also the use as well. So a great tool for being able to calculate your carbon footprint, basically just to make sure that we can be as green as possible. But we've got some really great graphics that pop out at the end, or some great results that pop out in the end, looking at the kind of the different impacts throughout its process. So from the material through to the use of the product, through to the end of life transportation, and also the manufacture of the part as well. So a really nice way of being able to evaluate our carbon footprint. And then finally, we've got Surface Flatten. Now this is a great tool for being able to develop any kind of organic shapes. Now obviously down in the standard package we can flatten the sheet metal parts, but we've also got the ability in premium to flatten more kind of organic and advanced surfaces. So a good example is that shoe there. We're going to have a look at this one in a bit more detail as well, because this is a brilliant tool. Just to give you an idea, there is a separate product available called Exact Flat, which does a very similar thing to this. So it's a very expensive bit of software. So we've got lots of customers that were looking at that actually they just upgraded to premium, and now they can develop and flatten their more organic shapes. Okay, so let's have a look at some of these in a bit more detail. So the ones I want to look at are Visualize Standard, so that's just included in the professional package, along with toolbox and part costing. And then down in premium, we're going to have a look at that surface flatten functionality as well. So switching over to SOLIDWORKS, I wanted to go through the toolbox to begin with. So this is the SOLIDWORKS toolbox that I'm going to use. A really simple assembly that I've got here. You can see I've just got some kind of plastic bracket maybe, and I've also got this piece of sheet metal underneath, and all I want to do is to put them together. I'm just going to bolt them together. Now importantly, what I'm going to do is use a PEM fixing. Now PEM is like a self-clinch nut or a riv bush or whatever you want to call it, and all I've done in my SOLIDWORKS model is this hole here. I've used the hole wizard to actually use the PEM standard. So we've within our hole wizard we can actually specify that I want a M6 PEM self-clinch nut to go in there, for example, and that means just that I don't have to pick up the reference from my specification book. So let's begin. I'm just going to open up my design library. It's in there, and at the bottom, let's just pin this open. At the bottom, we've got a toolbox. So this is our SOLIDWORKS toolbox. So as you can see, the first thing to realize is that obviously we've got all of these lovely flags. So this is basically asking you, where are you, or where is the product going to be manufactured, I guess, more specifically. I'm going to say that we're in ISO, I guess, for now. And I'm going to, in fact, sorry, I need to dip into the metric version of the PEM catalog to begin with. So we're going to use a nut. It's a locking nut, and I'm going to use this Trident self-locking nut to begin with, and I'm just going to literally just drag it on. You'll notice that it snaps into the right place. It also understands exactly the size it needs to be because I've dropped it into a hole wizard hole that's already got the classification of M6. So I'm just going to say okay to that. But what's really nice is the fact that not only is it, it's modeled that for me and everything else, but it's also dropping them into the right place as well, which is really useful. So all of those mates are then sorted out. I don't have to add additional ones if I'd have designed it myself and bought it in, I'd have to add lots of additional mates. So on the top, let's just dip into ISO and we'll have a look at some washers. But just to give you an idea, sorry, before I do that, just within ISO, we've got bearings and bolts and screws and pins and washers and power transmissions, so gears, lots of gearing in there, and nuts and all kinds of lovely stuff. So in washers, I'm going to dip into plain washers. I'm just going to choose my washer. You can see that these have all got ISO numbers specified as well. So I'm going to go for this one here. I'm just going to drop it into place. Just need to pick my size. So again, it's picked up on the right size. It's M6. And then again, I can drop it in, and as you'll notice, it's snapped into the right place, which is really useful. And then finally, under bolts and screws, I'm going to dip into hexagon socket head screws. That's always quite a nice screw. It's one of my favorites. And we'll use this dome-headed fixing here. So again, we just drop it into place. It finds the right hole. It's found the right size as well, so at M6. And what's really nice about the toolbox is that this little orange arrow, as I pull it out, it actually pulls it out into the sizes that are available for the M6 dome head using ISO standards. So we've got a 16 or a 12 that I can use, or even a 20. I'm going to go for the 16. I'm then just going to accept it, and then I've got one at my cursor that I can drop into somewhere else. But as you can see, really quick and simple to add all of our nuts and bolts that we might need to the design, and also that's including the bill of materials, the specification as well. Now we can customize that toolbox, so these things have got costs associated, or maybe it's a part number that's specific to ourselves. So a really nice way of being able to use our SolidWorks toolbox. Okay, let's have a look at so we've had a look at toolbox. Let's have a look at part costing. So let's just close that model down. So as you can see, we've got a fairly straightforward sheet metal component that you can see. Obviously, the nice thing about sheet metal is the fact that we can develop that, we can flatten that. But let's open up our costing tool. The thing we need to do is to basically choose the right template. Now, the template is something that you would tweak yourselves to include things like material costs, also maybe your own costs that you might know for, how much does it cost for a fold, or how much does your laser cost per, 10 mil or whatever. So this is something that you can basically define yourself. It's fully editable. Just for the purpose of this, I'm just using the standard one that comes with SolidWorks. So forgive me, it is in US dollars. And I'm sure the material cost isn't quite right, but you'll get the idea. So all it's doing is it's looking at the geometry. So it's picked up on the fact that, for example, we're looking at 3mm thick steel, but we can go through and change this. We can also ask it whether our blank size is being done on material weight, or more appropriately, I guess it would be sheet size. So we can specify the sheet that this is coming out of. We also then come down here and tell SolidWorks how many that we're making. So I'm going to say we're making a total number of 100 in a lot size of 100. We can also add a markup as well, or discount down there. So again, I can mark it up by 30% or whatever. So then all we do is we click on Begin Cost Estimation. It then tells me that that part, if I'm making 100 of them, is going to be about $11.88. And that's broken down into these things over here. So we've got setup. So we've got a laser setup and a bend setup. We've also got our cut paths. So you can see each one of those holes, for example, on the very outside edge is a cut path. We've also got the ability to then calculate the bends as well. So we're just saying that each bend is costing $1 pretty much. And also we can kind of add additional costs to that, such as powder coat or anodize or anything else like that as well. So it's a really nice way of being able to say, okay, well, it's $11.88, but what if I make this out of, instead of plain carbon steel, let's use galvanized steel instead. And you'll find that it updates there to $16.23. So again, it's a really nice tool for being able to do that kind of stuff. All I'm then going to do is just to create a very quick report. Now this uses Word, much in the same way that if you're using simulation tools, for example, when you create a simulation report, it uses Word to actually generate all of the stuff that needs to go into it. You can see it's just taken a couple of screen grabs for me. I guess this is exactly what I would do if I was creating a document like this myself, in that it's using Word to do that. And then it's dumped it down on a nice bit of paper for me. So you can see that this is actually a 3-page report, just coming up with the cost of this. And this is fully customizable as well, so that every time I create one, it might have your company logo on, or my name and contact details on there. So again, it's all fully customizable. So it's a great way of being able to document your quotation as well, not just saying to somebody how much it costs. So the only caveat there is that you need Word on your machine to do that. So that's a great way of being able to cost your parts. So let's then have a look at what we can do with Surface Flatten. So that's in Premium. So let's switch over to another model. So this is a Nike Air Jordan. It's been modeled by somebody with some skill, as you can see. I've just downloaded this from GrabCAD actually, just to use as an example. But obviously there's some flat patterns that would be really useful within this thing. So up on our Surfaces tab, we've got the icon here for Surface Flatten. Really straightforward. You pick the surface that you want to flatten. You then pick an edge to flatten it from, and SolidWorks goes ahead and actually creates that flat pattern for us. And if I just accept off the command, you can see, and again, I might just change the color of this as well, just to draw your attention to it. But that flat pattern there has then been developed from this really organic surface here. So again, to try and work that out manually would be very difficult indeed. And as I said, there's some hugely expensive software that does the same for this, but all you need to do is just to upgrade to Premium. So that's how to use a surface flatten. And then finally, we're going to have a look at SolidWorks Visualize. So SolidWorks Visualize Standard. So there is a professional version of Visualize as well that allows us to create fully rendered movies. But we're just going to look at the one that's included in the professional package, and hopefully you'll agree it's hugely powerful. So let's just switch back over to our model. And I just want to use this one here. So all we do on our SolidWorks Visualize tab. So if you've got it as an add-in and turned on, you've just got this tab here. And I'm just going to do a very quick export. So there's two ways that we can get our data into Visualize. We can either import it or we can export it straight from SolidWorks, which is what I'm doing here. Again, another nice thing about SolidWorks Visualize is that it actually allows us to open up lots of different types of file formats that we can't do in SolidWorks. So for example, if you're using props like people or plants or anything else like that, then often if you go online, they would be found on things like TurboSquid or 3D Content Central or GrabCAD, but they're often going to be in things like 3ds format or OBJ formats, which we can't generally open up in SolidWorks. So it's a really nice tool for being able to bring in those kind of assets to make it look ultimately a lot more realistic. So this is how it looks in SolidWorks Visualize. So let's just make a few little changes to this. I guess the first thing, there's only three things that we really need to do. We need to concentrate on the appearances, which actually it by default brings in the ones that are specified in SolidWorks. So you can see it's already set up as it looked in SolidWorks. We also need to specify the lighting. So, where am I? Am I in a studio? Am I outside? And then we need to specify what's going on with the camera. So very quickly, I'm just going to change the appearances to be a slightly different color. For example, maybe this thing here. So at the moment that's down as this leather kind of material. I can actually come in here and I can maybe change the color of it. So really simple. Again, it's just drag and drop if you need to. So I'm just picking the ones that are already there kind of thing. But if you wanted to use drag and drop. Also, let's maybe just add, nice thing about this as well is that we can really get in there and start adding lots of texture to it as well. So with this white plastic, I'm just going to add what we call a bump map, which is going to give it this kind of texture. So let's just, in fact, let's just make it a little bit smaller, that texture. And also I can change the color of that just for that inlay to be maybe a slightly darker gray maybe. See, perhaps I'm a frustrated shoe designer. So you can see how easy it is just to tweak materials and things like that. The next thing that I want to do really is to concentrate on the environment. So at the moment I'm kind of in a studio environment. And now this scene has come from SolidWorks. So if I just dip into my environments, I can take it into a warehouse, for example. Again, now that's being lit by my warehouse. So if I just turn off my backplate and just zoom out a bit, you can see that I am actually in a kind of 360 degree warehouse there. Now, to light this properly, I'm actually just going to drop it into an outside environment. So perhaps I could take it into a California desert. But you can see the lighting conditions are all changing. So now we've got these really nice shadows going on. Or I could take it into a dirt road. So that's nice and bright. So we'll use that as a lighting condition. So that's how it's being lit by this kind of outdoor environment. Again, that's a 360 degree photograph. But actually, I don't want the photograph in the background. I just want a plain appearance. So let's just take my scene and I'm going to add a backplate to this. So we'll just drag the snow cloud across or make it visible. And then what we can do is to take our lighting condition, so our kind of environment that we're using, and then I can kind of rotate it around. Now the nice thing about this is obviously it changes our shadow direction. Can you see that? As we're moving our scene around, it's actually giving us shadows in different orientations. So that's where I want my shadow to be. So the sun's kind of coming from this side. And then once we've done that, I can start working on my cameras. So I'm just going to copy and paste that particular camera. So this basically captures the camera orientation. So maybe that's a really nice shot for me. Maybe I'd like another one that's kind of like that. Maybe I'll just skew the perspective a bit. So I'm going to copy and paste that one. Perhaps you want a nice side-on shot like this. So I'll copy and paste that one. And then perhaps a nice rear shot. That might be quite nice as well. Now, once we've got those cameras, we can actually do some funky stuff with them as well. So I'm going to go back to this one where it's at the front, because I just want to show you some of the really cool tools that we've got that allow us to set a depth of field to it. Now, obviously, if I was going to shoot this with like a DSLR, then some of it's going to be in focus and some of it isn't. So all I'm going to do is on my cameras tab, under the general tab, we've got the ability to turn on depth of field. I'm going to pick Michael Jordan as my area of focus, and just to exaggerate this, I'm just going to blur it a bit more than I normally would, but just to emphasize what's going on here. So I've basically, you can see Michael Jordan's in focus, and then the rest of what's in the foreground, and also if there was stuff in the background, that would be blurred as well. I'm also going to copy and paste that. I'm going to change. I'm going to pick the front of the shoe this time, and then blur out the back of it, maybe not quite as much. But you can see now that we've got two images. So we've got this one here, which is where we've got the shoe in perfect focus, the front of the shoe in perfect focus, and you can see Michael Jordan's blurred out. And also, if I go then back to the other one, you can see that Michael Jordan is in focus and the rest of the shoe is blurred out. So again, really quick and really straightforward to be able to make some really nice images. And that's SolidWorks Visualize. So again, that's one of the main reasons that people upgrade to either professional or premium, because we get that. It's one of my favorite tools. The images that you can create in there are simply stunning. So worth an upgrade, if not just for that. Okay, so that brings our webinar to an end. Thank you very much for joining us today. That's what you can expect if you upgrade from standard. Thanks again for your time. Bye-bye.